Check. Hi, everyone. Good morning. So thank you for joining me here. My name is Gautam Dhameja. I work with Parity Technologies as a solutions director. And today I'm going to talk to you about blockchains that evolve. We have different kind of use cases. We have different kind of users. We have different kind of features. And how do you make sure that the blockchains can keep up with those requests, demands, and issues? All right, so let's get started. So the first thing I want to ask you is, if you see my slide now, what do you see that is a similarity between these three terms? What do you think, is common among these three? Exactly. So people change. We always want to become the best version of ourselves. Time changes. I still have like 27 minutes left now because last moment I had 26 or 28 minutes left. Climate, well, it was 41 degrees yesterday in Paris, so climate is definitely changing. And clickers also change. My clicker is not working right now. It works now. Okay. So blockchains, it's a little hard to make them change. When there is something new that needs to be done on a blockchain, it takes some time to get it in there, get it going, and so on. So yeah, it's hard to upgrade blockchains. It's hard to get your blockchains together when it comes to change. Now, with this premise, I want to also come to the point where we say that there is a change sometimes needed. Sometimes there are triggers. Sometimes there are circumstances that require you to upgrade your blockchain. Let's look at those. Okay, this is the way. Protocol upgrades. Most of the time when you want to change the protocol or you want to upgrade something on the core rules of the protocol, there is a change required that needs to be done on the solution or on the app or on the smart contracts. Just to make sure that you are optimizing it for the latest version of the protocol, or maybe your app represents a protocol in itself and you want to upgrade that. Optimizations are needed most of the time because when the market conditions change, a lot of things change along with that, and then you want to optimize your code to fit those conditions. Of course, like sometimes we want to fix things that were not so right in the first place, so bug fixes are needed because it's just software at the last. And finally, users, and users come with requests. So there are a lot of times when we want to incorporate those requests in our blockchain solutions. So what do you see? All of these triggers or all of these things require you to change the blockchain. And what changes? As part of those triggers, where does it impact the most? Where do you have to really change things? Is first of all, of course, the business logic. Whether it is in the smart contracts or in the core layer of your blockchain, in the state transition function itself. Incentives change because people change, like I said in the beginning. When people change, incentives have to change for them. Rules change because, again, it's the people thing. And finally, a lot of times, the data needs to change as well, like how you represent your data to make sure those optimizations are coming in. So in the previous one, we saw that there are some triggers. These are the targets. This is where the change actually happens. And most of the time, to incorporate all of this change, the technology itself has to change. The underlying technology that we are mostly building on, that changes as well. So it basically is like, everything keeps changing. And then when we want to bring something together, it's hard to make it from a overall point of view. So let's see how that looks as an example. So I'm taking a very basic example here. Let's say there is a DeFi platform, and they want to incorporate some new protocol on their app, essentially. And because of this new protocol, they are making some optimizations. The data needs to change, the schema needs to change, and so on. So they cannot just use upgradable smart contracts in this case. It's hard because the data schema is changing. There are a bunch of other things, and it's a limitation. Now, what you have to do in this case is all of this. You have to first upgrade your smart contracts with the new version of the protocol. Then you have to migrate the data because the schema has changed. You have to then, of course, do the basic things, test, audit, then deploy. And finally, the most important painful thing, your users have to look at the new addresses of these smart contracts. They have to update their side of things. Exchanges and wallets have to make the changes, and this is painful. This is not user-friendly. Now let's look at another example, more from an enterprise perspective. So most of the time, this is how generally blockchains are implemented in large-scale systems, that there are multiple parties coming together to verify data. And let's say in this situation, there are multiple parties, and there is a new party that needs to join this particular consortium or solution or whatever you want to call it. And this brings together with some new parameters, some new integration aspects, and so on. So then this again requires a change in your system. This requires you to upgrade some of the parameters that you are already working with, requires you to integrate some new systems through oracles or so on. And then again, the same painful process comes back. So update the smart contracts, migrate the data, and blah, blah, blah. So it's, when we want to really change something, we have to go through a lot. And this is essentially slowing you down. This is essentially making things much more, you can say, slower to market. In this time when blockchain technology itself is moving so fast, we want to go so quickly to the market with our products and try them out. This process just doesn't allow that. This process makes us slow. So what do we do? Now, it's not just about the technology. It's not just about this particular process or so on. There is more. There is more to it. The governance aspect. So there is no admin. There is no one single person that can just go and upgrade something. Or even if it is allowed, even if it is needed, it's really impossible. So how do we ensure that we align these all different stakeholders to actually agree on something in a faster manner, in a more efficient manner? Because if you look at how off-chain governance is done these days, it's like, people want to collaborate on calls and Google Docs and everything, but how much of that really goes on the chain and how fast? And the more important thing is, how do you enact those rules that you have been talking about with these different people? So it's, again, there is a technology problem and there is a people problem. And how do we bring this all together? So that is where we call something as evolving blockchains. It's more like, an abstract idea, but the concepts that I'm going to talk about now, it's going to bring this together. So bear with me and let's take a look at what this really means. So let's think about these two problems, the technology problem and the people problem. What if we have a very efficient on-chain governance process? Will that make things faster from a people perspective? Will that allow us to quickly agree on something in a most verifiable manner and then try to enact those things on the chain? So that is where, we want to simply look at the people problem and tackle it in a more efficient manner. What if people don't have to fork at all? What if they just can get their blockchains upgraded with a much more simple and seamless process, that there is a transaction, a special transaction that happens with everybody's agreement on it, maybe a multisig, maybe a democracy-related voting mechanism, and then that transaction happens and everybody's nodes gets upgraded, forkless. What if the state migration or the storage migrations that users have to worry about, that exchanges have to worry about, can be done in an automated fashion? It can abstract away every pain from the user and can be part of the runtime upgrade process or the blockchain upgrade process itself. And finally, what if you have a completely extensible framework that allows you to go from version 1 to version 2 in a much faster and scalable manner? What if you can just build on top of what you have instead of building something from scratch, instead of not reusing the primitives that you have already defined? So I look at these 4 things as pillars of evolving blockchains. If you have these 4 things, if you can work on them on your blockchain solution, then probably your blockchains will evolve faster. They will be faster to market, they will be closer to your users, and they will probably bring you feedback in a more efficient manner. So this is where Substrate comes into the picture. This is essentially, you must have heard of this framework that Parity has created. This is basically a blockchain development SDK built in Rust. And it allows all of those 4 things to have evolving blockchains. So let's take a look at all of those things together. On-chain governance. So essentially, Substrate, just to give you a little bit of a brief, overview, Substrate is a fully extensible and modular framework, and this has basically a thing called runtime, which is basically the state transition function of the blockchain, and that is composed of different kind of modules, which we call palettes. Now, Substrate has these inbuilt on-chain governance palettes that ship with Substrate, fully audited, fully production ready, and then you can use them in your blockchain at any point in time. So your blockchain can become completely on-chain governed by using these palettes, and you can extend and you can improve them if you want. If you want, like a more fancy version of these, you can just build on top of these. So that's the first pillar of evolving blockchains supported by Substrate, the on-chain governance. Forkless upgrades. Again, the second pillar of evolving blockchains. What if there is no fork needed? What if people don't have to download a new node every single time there's a change in the blockchain happening? What if there is a special transaction that happens through the governance process? This is it. So Substrate, basically, the state transition function, the runtime is just a WASM blob. And this special transaction, that the forkless upgrade transaction that we call, it can simply replace this WASM blob with the next version, and everybody gets the same, runtime on their nodes. So they don't have to download a new node at all. They don't have to worry about basically forking the chain or connecting to another fork or so on. It can just simply get upgraded using this process. And it can be upgraded while all the nodes are still running. Nobody has to stop their nodes as well. So again, forkless upgrades supporting evolving blockchains. State migrations or storage migrations. So when the upgrade really happens in Substrate, it allows a couple of hooks where you can write some functions, which we call migration functions, and they can just pick up the state from the old state or the old schema and put that into the new schema while as part of the upgrade process. So basically, you can write your migrations. It's just simple, like writing simple functions where you pick up the data and put that in the new storage. You run the upgrade process, the special transaction, and then after that, a hook comes in, which is called on runtime upgrade, where this function can run and migrate all of the data for your users. You don't even have to worry about anything. And finally, extensibility. So think of a scenario where you have a node and you just have to upload or deploy smart contracts on it. That's a pretty black box approach. You don't have any control on the state transition function itself. You don't have any control on optimizing those smart contracts for different kind of use cases. You just need to deploy those smart contracts. Not user-friendly, not developer-friendly, pretty much. But what if you have full control on extending everything inside your blockchain? You can change the consensus. You can change the crypto suite itself. You can change the APIs and networking, storage, everything. Of course, Substrate comes pre-packaged with a very optimized implementation of each of these things, but you are fully free to extend any of those if you have something written in Rust. And then, of course, the state transition function, which I spoke about previously in the forkless upgrade Spark. This is a WASM blob, which is, of course, upgradable at runtime. So extensibility allows you to basically build on top of what you already have with the same primitives and allows you much faster upgrade or much faster change in your blockchain. So that's the fourth pillar. So if you bring all of these things together, your blockchains become much more evolving, I believe. So maybe it's not so hard to upgrade blockchains anymore if we are using Substrate. It's more like, you can say, a way to go faster to the market, a way to cater to your users much more seamlessly and much more efficiently, and a way to actually have more fun while building blockchain solutions from a developer's perspective. Because you can try different things, you can experiment, you can essentially evolve with the solution as your knowledge as well. So Now, just to give you a little bit of sneak peek into what this looks like in the real world, some stats from our ecosystem. So in the Polkadot ecosystem, we have had more than 100 forkless upgrades in the last few months itself. The community came together, the governance played a part in this, and then when everybody agreed, we did a forkless upgrade of the protocol. More than 1,400 engaged participants participated in these upgrades from the governance process. And finally, in the entire ecosystem, we have had 621 plus forkless upgrades across all of, you can say, substrate-based chains in the Polkadot and Kusama ecosystem. So what I spoke about, this really works. This is already in practice. This is fully production ready, and people are using it. So that is evolving blockchains for you. Thank you so much for listening. Any questions?
Testing. Yep. So yeah, some of these changes, look like they're obviously at the blockchain level. It's quite a fundamental change. Like, is there any granularity of the users that can opt into that or opt out of that? So would you effectively get forks of the blockchain just by virtue of people sort of signaling into the change or not? Or is it majority votes and then everyone changes across? Because I just think of use cases where someone may have had an expectation of certain functionality for the long term, so they built their smart contracts, got them audited and all that process, but then effectively the floor is shifted from under them because it's at that lower level. Is there a way that they can preserve the chain they started on, or do they just have to take this upgrade?
So I think there are two things here. First of all, thank you for the question. Very, very good question, because I forgot to mention one thing, that this upgrade process is for the state transition function of the chain. Essentially, it is not for the smart contracts. So it is one layer below already. So when you are building your chain using Substrate, not just the smart contracts, the entire blockchain for your use case, then you are basically able to upgrade, and then your community plays a role in upgrading that chain, essentially. So if their users are still deploying smart contracts on top, their smart contracts are not changing at all. It's just the state transition function that is changing. But in most cases, because these chains are fully use case optimized, they are application-specific chains, that is why the smart contracts are not on top of them. The state transition function plays all the major roles in terms of functionality already. So this is not for smart contract platforms, but for application-specific blockchains. There was one more question.
Thank you for the presentation. So if I understand correctly, so you already have more than 100 upgrades on layer 0 on Polkadot and Kusama. And so it's something maybe similar to the other questions. I guess it's really the governance that is important in this case, because you should agree to upgrade. How do you, what is the consensus, and how can you participate to this consensus?
So essentially, anyone who wants to participate can participate. They just need to, when you are voting, you need the DOT token or the KSM token when you are participating in the governance process. So as far as you have the token, you can participate in the governance. It's fully open, fully decentralized.
Okay. And in terms of consensus, how much do you expect to, how is worked the quorum? Is that you need 50% of or 51% of the voters?
It's basically, different from proposal to proposal, essentially. So when people propose something, sometimes, the majority or super majority consensus is needed. Sometimes, normal majority. Sometimes it's a council-based consensus that is needed, and so on. But there is a new version of governance also coming in. It's underway. Like last couple of weeks ago, it was announced in Polkadot Decoded that we are working on governance version 2, which will make this even more, you can say, flexible and configurable in the future.
Thank you very much.
All right. Thank you, everyone. Have a nice morning.